Okay, so now that you're an expert on reading solubility curves and graphs, we're going to take it one step further and we're going to talk about solution saturation. Now remember, a solution is just a mixture of that solid and the liquid, just like in the solubility piece that you've been working on for the last couple of days. So we got to talk about what this part saturation means. And we are going to write a couple things down here. So a saturated solution really just means that the solvent contains as much solute as it can possibly hold. So we know we talked about our Kool-Aid example, and that you can try to make your Kool-Aid as sweet as possible, but that water can only hold so much sugar, and pretty soon it's going to stop dissolving because it's what we say full. Or another word that we can use now is that it's saturated, meaning that that water is holding as much sugar as it possibly can. It's full. On our solubility graphs that we've been working with, the line for each chemical represents the point of saturation. That represents when the solution is full and you can't dissolve anymore. Okay, so if we look at this example, at 15 degrees Celsius, what is the maximum amount of potassium iodide that could be dissolved in 100 milliliters of water? So we find 15 degrees Celsius, which is here. We're doing potassium iodine, which is this line up here. And we're going to follow that 15 degrees Celsius up. And how much can we dissolve max? Remember that this line represents a saturated solution. So we hit that line, we take a turn. It's just a little bit less than 160, maybe 155. Okay? So that line represents a saturated solution. Anytime you get a question that says that the solution is saturated, you draw your information directly off the line. Okay? Not all solutions are saturated. Sometimes they're unsaturated, and what that means is that you actually could dissolve more solute in there if you wanted to. That it's not full. It's kind of like you have your Kool-Aid. You could make it sweeter. You could put more sugar in there and it would still dissolve. It's not full yet. Okay? If you're reading a solubility graph, this would represent any area below the line. So if we're looking at this example here, it says if you dissolve 70 grams of potassium nitrate at 60 degrees in a solution, can you dissolve more? So first of all, potassium nitrate, okay, that's this line here. Remember, any information directly on the line represents a saturated solution. Any area below the line, which is all of this, if our numbers fall in that area, then we know that the solution is unsaturated. So we're going to dissolve at 60 degrees. We're going to dissolve 70 grams, which is right here. And you can see that that spot is actually below this line. So that spot is in the unsaturated territory. So if we were to dissolve 70 grams at 60 degrees, we would have an unsaturated solution. Okay, well, how much more could we dissolve then? Well, you can dissolve more until it's full. Well, at 60 degrees, what's the most that will fit in there? Well, we go up to the line. Looks like it's about 110. Okay, so we only dissolve 70. We could dissolve up to 110, so how much more can we add? That's 40 more grams to go from 70 up to 110. Okay, now remember, anything below the line is considered unsaturated. Okay, the third instance that could happen is you could have a supersaturated solution, meaning that it's actually holding more than it normally could. Now, in order to have more solute dissolved than it normally can hold, you have to actually heat that up. And we use this process a lot in making candy. So in order to get a lot of sugar dissolved into a liquid, we heat it up, and then when we cool it down, that sugar stays in solution, meaning that it's supersaturated. It's holding more sugar than it normally would. Now, if you're looking at your solubility graph, this would be anywhere above the line. So in our potassium nitrate example, remember, here's our line, our saturation line. Anything below the line represents an unsaturated solution, and anything above that line represents a supersaturated solution. So if I were to say at 45 degrees we dissolved 130 grams of potassium nitrate, that would be right there. You can see that that spot is well above this line, and therefore that solution would be considered supersaturated. Okay? You have lots of practice to try these with. You have your solution saturation worksheet you can grab, and there's a front and a back on there. Work your way through those, and if you get stuck, ask for help right away.